everyone, we welcome you. Myself Dr. Babu. I was working as an assistant professor in the Department of Electrical and Electronics Engineering at the University of Surampalem. Today we are going to discuss about three-phase circuits. In that, now we will be discussing on analysis of three-phase unbalanced circuits by using Milliman's method. In the previous lectures, we have discussed about star delta transformation technique and loop method also. Now we are going to concentrate on Milliman's theorem. In order to start this, everyone should know the basic concepts of Milliman's theorem, which were discussed in the previous classes. So coming to this theorem, with the help of this theorem, here we are going to solve the analysis of three-phase unbalanced circuits. So for that, we need a source and load. So if you observe this diagram, means this side part is called as source and this side part is load. So if you observe this, means here VRO is the source across R phase and VYO is the source across Y phase and VBO is the source across B phase. That means this part is source side or generation side. Now whatever the power we have generated is to be transmitted to the load side. So coming to this load side, this VRO dash is the voltage across this R phase and the impedance across this is ZR. In a similar manner, this VYO is the voltage across Y phase and the impedance across it is ZY. In similar sense, the voltage across this VB naught dash is ZB. Okay. In order to avoid ambiguity, here I am keeping the notation as O, and for the load side, here I am keeping the notation as O dash. Okay. That means VRO, VYO and VBO are the voltages across R phase, Y phase and B phase on the source side, and on the load side, VRO dash, VYO dash and VBO dash are the voltages across the load side. Also, this ZR, ZY and ZB are the impedance across R, Y and B phases. Okay. Now this is about load side, source side and load side. Now whatever the amount of power that is generated is to be transmitted to the load side. So for that purpose, the IR is the current that is passing through R phase of both source and load. In a similar manner, IY is the current that is being transmitted to Y phase and IB is the current that is being transmitted to B phase. Okay. Now if you observe this, means the voltage across the load and source neutral points, among the neutral points is VOO dash. Okay. Now coming to this Milliman's theorem, it states that the VOO dash, that means voltage across the two neutral points, is given by VRO into YR. That means this one VRO into, that means source voltage into the impedance across R phase, admittance across R phase, that is YR, and VYO into YY, that means the voltage across Y phase with the impedance across the Y phase, plus VBO, that means the voltage across the B phase multiplied with admittance across the B phase. Okay, divided by sum of all admittance. That means here VOO dash is equal to VRO into YR plus VYO into YY plus VBO into YBY, YR plus YY plus YB, where YR is equal to 1 by terms of ZR, okay, and YB is equal to 1 by terms of ZB and YC equal to 1 by terms of ZC. YR, YB, YC are admittances of R, Y and B phases. Okay. And also this VRO, if you have taken this VRO as reference, VRO is given by VRO at an angle of minus 30 degrees and VYO, okay, VYO is VRO at an angle of minus 150 degrees and VBO is VRO at an angle of 90 degrees. That means in all the three cases I have taken VRO as reference. Okay. VRO means VRO at an angle of 30 degrees minus 30 and VYO is VRO at an angle of minus 150 and VBO is VR at an angle of plus 90 degrees. Okay. These are the voltages. Now coming to the calculation of voltages, okay, this one VRO is the source and VOO dash is the voltage across the neutral points among the source and load and VRO dash is the voltage across the load. That means here we can write VRO is equal to VRO dash plus VOO dash. That means source voltage is equal to load voltage plus connection between the neutral terminals. This is for R phase. In a similar manner, if I write it for B phase, VBO is equal to VBO dash plus VOO dash. That means VBO is equal to VBO dash plus VOO dash. This is for B phase. And a similar manner, if I write it for Y phase, VYO is equal to VYO dash plus VOO dash. This is for Y phase. Okay. Am I clear? Now I have written all the voltages from this. I can write it the load voltage VRO dash is equal to VRO minus VOO dash. And a similar manner, VYO dash is equal to VYO minus VOO dash. And VBO dash is equal to VBO minus VOO dash. Okay. Now here I have calculated the values of line voltages and phase voltage I have calculated. Now I need to calculate the values of line currents or phase currents, both are same. So in order to calculate the line current across the phase IR, okay, IR means the current flowing through this R phase. Okay. So IR is given by voltage across the R phase, that is VRO dash divided by impedance across it, that means ZR. Okay. Therefore, IR is equal to VRO dash divided by ZR, where we know that VRO dash is from this formula, that means from here VRO minus VOO dash. Okay. That means IR is equal to VRO dash by ZR, and VRO dash is VRO minus VOO dash by ZR. And in a similar manner, we need to calculate the values of current IY and IB. For IY is this part, VYO dash by ZY, and VYO dash is VYO minus VOO dash. And a similar manner, IB is equal to VBO dash by ZB, and where VBO dash is VBO minus VOO dash by ZB. Okay. Like this, we need to calculate the values of line currents and phase currents. Now, we will solve a numerical so that we will be having some idea of how to solving the numericals with the help of this milliamps method. If you look into this problem, here it states that find the value of IB in a 3-phase circuit, showing that they have given the values of ZR, ZY, okay, and ZB value is not given. So at the first instant only, if we haven't considered ZB value, means it will be something bit complex, because Z is Y equal to 1 by Z. So in order to eradicate this, I am assuming the value of ZB is equal to something 10 at an angle of 20 degrees. Okay, it's an assumption, I have assumed it. Later on we will solve the exact numerical. First it's my assumption, okay, where ZB is equal to an angle of 20 degrees. So here ZR is given, ZY is given, and ZB is also given. And also they have stated that the applied line voltage is equal to 100 volts. Okay, we got the line voltage. In star connection, okay, line voltage is equal to root 3 times of phase voltage. This one we have derived the equations in the previous relations between line voltage and phase currents in star connections. So from this, V phase is equal to 100 by root 3. Let it be VRO dash. That means as per the previous derivation all things, VRO dash is equal to 100 by root 3. Now I need to calculate the values of VBO dash and also VYO dash. Okay. Now VYO dash is equal to 100 at an angle of root 3 at an angle of minus 130, and this will be at an angle of 30 degrees. Okay. This one will be at an angle of 30 degrees minus 30, and this one will be at an angle of minus 150, and VBO dash value will be 100 by root 3 at an angle of plus 90 degrees. Okay. These all are my phase voltages. Now I got the values of phase voltages. Now I need to calculate the values of voltage across the two potentials VYO dash. We know that VYO dash formula is, okay, V R B by IR. See, from this we got it, VRO by YR. Okay, VRO into YR plus VBO into YB plus VRY and B, VYO into YY divided by YR plus YB plus YY. Okay. Now here I got a value of ZR, where YR is equal to 1 by ZR, that means 1 by 5 at an angle of 30°, and YB is equal to 1 by ZB, that is 1 by 2 at an angle of 60, and YC equal to 1 by ZC, that is I have made an assumption right here, see 1 by 10 at an angle of 20°. Okay. Now you need to calculate the values of all Y, R, Y and B phases, and you need to substitute the values of VRO and VYO and VBO. Okay. Here both are same, so substitute the values of VRO, VYO and VBO. Okay. After substituting all the things, we get the value of VOO dash and VRO dash, we got the values. Now I need to calculate the values of IR comma IY comma IB. So for that I am erasing this complete part. Okay. Now IR is given by IR is equal to VRO dash by ZR, where VRO dash is nothing but VRO minus VOO dash by ZR. VRO is nothing but 100 divided by root 3. Okay, at an angle of 30° minus VOO dash, we have calculated it, substitute it and get the value of IR. And in the similar manner IY, VYO dash by ZY, and VYO dash is nothing but VYO minus VOO dash by ZY, and VYO dash is at an angle of root 3 at an angle of minus 150 minus something divided by ZY. And in a similar manner calculate the value of IB. Therefore, we got the values of IR, IY and IB. So, like this we need to solve the numerical, but in the exact problem they haven't given the value of ZB. That means ZB need to be 0. That means if ZB is not given, we should be considered as 0 ohms. Okay, if ZB is 0 means YB is equal to 1 by 0, that means infinity. Okay, so in the calculation of VOO dash, okay, something numerical by denominator ZZ will be there, say YY will be there, so that way that value will be infinity by infinity. Okay, the value will be infinity. So like this we need to solve a numerical with the help of Milliman's method. Okay, coming to the summary of this topic, we have discussed about Milliman's theorem. In this we have calculated the values of VOO dash, that is line voltages, voltages across the both source and load, and after that we have calculated the values of line voltages and phase voltages. Based upon the line voltage and phase voltages, we have calculated the values of line currents and phase currents, both are same, and with the help of that we have completely solved the with the help of these equations we have completely solved the numerical, and this method is mainly used for the design and analysis of electrical circuits. So with this we can conclude this session. Thank you.